As mentioned previously, the map, filter, and reduce methods are used extensively within a functional paradigm. However, I don't believe that is the only reason to learn these methods. Even if you don't use many techniques that are traditionally used in functional programming, you should definitely use these methods when working with arrays. They are critical. Now, to introduce the map, filter, and reduce methods and how they are more declarative, I want to present a simple scenario that we will solve first with a loop and then use one of these methods. All right, so I have here an array of scores. As you can see, I think, let's see, we've got about 8 scores. Yeah, 8 scores there. And let's say I wanted to sum them. I wanted to get a total of all these scores together. Well, to do that with a loop, we declare a variable, something like sum here, and set it equal to 0, and then we go ahead and loop through the values. One way to loop through that with a for loop here, set I equal to 0, and we run the loop until I is less than scores dot length. Now, as you can see, what we're doing here is very imperative. I'm telling the system exactly what to do. We start while I is 0, we go until, we go while I is less than scores dot length, and then each iteration we increment I, and so it gets larger. Then we use that, the I that is, to add the score to sum. So scores, and here's how we do that. We put I inside of square brackets like that, and that indicates which value we're working with, which element of the array we're working with. And so we're being more imperative about that. We're telling it exactly how to go through and process each of these values. So obviously, if I just save that, I'm going to reduce this a bit here, and we take a look at the console, we should be able to see that sum is equal to 550, and it is. So that worked for us. Now, with these methods, with reduce, map, and filter, they take care of the iteration for us. So they're automatically set up to iterate through every element in an array. Now, what do they do with each of those elements as they iterate through is they pass each value, each element, into a function. We have to provide that function to the method. And so once we provided the function to the method, the reduce method, the map method, the filter method automatically send that value to the function. The function does whatever we programmed it to do, returns the value, okay? So that's basically how they work. So knowing that, let's say we want to set up a function here. I'm going to call it some fun, indicating it's a function. And basically what it's going to do is it's going to have what I'm going to call an accumulator value. So this is an ongoing value. This value keeps getting values added to it. It's similar to this sum variable here. Each iteration, the sum variable became larger and larger because it had values added to it. That's what this is going to be. This is our accumulator. And then I'm also going to have a parameter for this function called current value. Now this parameter is going to have the current value from the element of the array that we are currently on. So as reduce, and I'm going to use reduce first, as reduce is iterating through the elements of this array, it's going to place the value of each element into this variable here. And so what would this function look like if we wanted to get a sum? Well, basically, we would do something like this. Very similar to what we've done right here. It's basically the same idea. This accumulator value is simply getting the current value added to it. And it will keep getting that added to it as long as new values are passed into the function one by one. Okay? So this function has been set up specifically for the reduce method. So how do we go ahead then and make use of it? I'm going to use the same variable, sum, that we declared up here, scores.reduce. That's how we access these methods. These are methods of arrays. So we use the dot method the dot syntax to access these methods. Now, the reduce method takes two parameters, and notice that we have a reduce right as well. Basically, the difference between reduce and reduce right is reduce comes from the left, reduce right comes from the right. That's the difference. Now, with both of these methods, they take two parameters. One is a function, some function that we pass in, and the second thing is the initial value for the accumulator right here. What is that initially going to be? What do we want it to be before anything is added to it? Well, up here we set the initial value to 0. We do the same thing there, and so it will be 0. Now, what function do we want to pass in? Well, of course, we want to pass in some fun. And so that function will be passed in. Reduce already takes care of the iteration for us. We don't have to do any of this. And that's why it's more declarative. We don't have to worry about that at all. We just pass in the function that's going to do the adding of the values. So let's go ahead and save this, and we'll take a look at that sum variable again, and it should still be equal to 550, which it is. So that worked for us. Now, at first, you're going to say that using these methods, I've only showed you the reduce so far, but using these methods are harder than just figuring out things in a loop. And that's because you're used to using loops. If you do feel that way, that's the reason. That's how I felt when I first started using these methods. I was used to loops. I could solve things with loops because I'd done them 100 times. But as you begin using them, these become just as easy. And they're declarative. You're not so concerned, even though this part becomes secondhand for you, you're not so concerned at telling the system how it should process the values or what it should do. You're more concerned about, well, we're going to get a sum, so we're going to add values together. Now, you may also look at this and say, well, reduce is pretty limited. With sum, we could be doing multiple things. For example, we could add a count variable in here and get a count of the number of times it goes through, and then we could get an average. Well, what if we wanted to do multiple values within reduce? Before I leave reduce and go on to map and filter and show you quick examples on those, I do want to show you this bit of reduce. This is important to understand with reduce because reduce can be very powerful and is probably used more than the other two methods. All right, so here's how we can do that. I'm going to create another function. Now, one other thing I should say. Here, I've created the function before, and then I've placed it inside the reduce methods. A lot of times, you'll see the reduce method or the map method or the filter method used with an anonymous function, meaning the function is declared inside this. For example, we would have this part right here, right there in place of some fun, okay? And it would work the same way, we just don't have to declare the function beforehand. But there are reasons you may want to have your own library of functions that you use. And so you declare them before, you use them in each of your projects. This would be a way to use it within these methods. Okay, so we're going to create a new function. It's going to be sum count average. That's what I'm going to call it because it's going to do all three things. So here's how we'd set that up. We still want the accumulator value at the start, but now I'm going to make it an object. That's how I deal with more than one value. I store them in an object, and we want the current value as well. So that's a big difference here. If we want to do something more than one thing, we can use an object to do that, or an array if we choose to. I prefer to use objects for these kind of situations. Now here's what we're going to do. We are going to return an object. Okay, this accumulator value is an object. We want to return an object. Every time we return something, like up here, after we've added the current value to the accumulator, it gets returned and gets placed back in that accumulator value. We add it again, it gets replaced back in there. That's what we're going to do here. We're going to return an object. It's going to be replaced in this accumulator object. We'll do something with it, return an object again, and so on, as it iterates through every value in that array. All right, so here's the object we're going to return. We want there to be a sum property, and what is that going to equal? Well, it's going to equal the accumulator object dot sum, so whatever value is there already, plus the current value. See how we did that? So since we're returning an object, we want to grab the value from the object, which is what we're doing there. We add the new value to it. We return the object again. Now that's just one value. We also want to count. So how do we do count? Well, count is going to be like this. It's going to be another property, count, and that's going to be equal to the accumulator object.count. So we're grabbing that count as it currently exists, and we're adding 1 to it. That's how we're increasing our count. Then how do we get the average? Now the average I'm going to compute each time through. So after we've gone through maybe 3 numbers, we'll still have an average even though we haven't gone through them all. That's how I'm planning to do this here. There may be other approaches. That's the approach I want to use. So here's how we get the average. I'm going to get the accumulator object.sum value and add the current value just like we did up there. And that's inside of parentheses. And then I'm going to divide that by, guess what? The accumulator object.count value. And I'm going to add 1 to that as well. And that's inside of parentheses. Okay. And then I'm going to just put that at the end there. Semicolon at the end. Now let's go ahead and try this out. So I'm going to use a new variable here. Let result equal scores. That's our array. Dot reduce. That's how we access the method. And what do we want to pass in? Well, the sum count, average function. That's what we're going to pass in. Now remember, reduce has 2 parameters. And the second parameter is the initial value of that accumulator. So what do we want the initial value to be? Well, in this case, it's an object. So let's pass in an object that has initial values for us. Sum is equal to 0. Count is equal to 0. And average is equal to 0, just like that. That's our initial value. All right, let's save that and take a look at it. If I come back out and look at result, I think I did singular, yep. The sum is 550, count is 80, the average is 68.75. So there we were able to do something more than a single number with reduce. Now, this particular video is getting a bit long, but I do want to make sure that we do an example of map and filter. Now, map is used when we want to process the entire array and return a new array with something different for each of these values, okay? So let's say, here's an example. I wanted to convert the scores in the scores array to a decimal representation from 0 to 1. So the way I do that is I have to divide each of these by 100. So we get a 0.9, a 0.3, we'd get 1 over here. That's what I want. So let's go ahead and set that up. So I'm going to call this function decimal score. We're going to receive a value. Now with the map method, we only need to have 1 parameter in the function. And because I only have 1 parameter in this arrow function, I don't need to put parentheses around it if I don't want to. And what are we going to return? Well, as each of these values are passed in to the map method, what do we want to do with them? We want to divide them by 100. So I simply return val divided by 100. As simple as that. Okay. Now let's go ahead and set this up in the map method. Let's declare a variable, call it decimal scores. This is our new array. And we're going to access the current scores array, and we're going to use the map method this time, map. And what are we passing in? Decimal score, that function, okay? Now the map method takes 1 parameter, that is all, and it is the function. So if we save that, let's go ahead and take a look at decimal scores. And there we go, they're converted. We have a new array with the scores showing this way. It didn't change our existing scores array, it returned a new array. That's another important point of these methods that I'll address soon. All right, one last example, filter. And here's the example for filter. What if I wanted to remove scores below 70? I didn't want to include any that were below 70. Let's say everything above 70 and above are passing scores. So let's go ahead and set up that function. Now, filter method what it's going to do is return a new array as well. Just like map did, it's going to return a new array. The difference is the function that filter uses to check each element needs to return either true or false. If that function returns true, then the value of that element is included in the new array. If it returns false, the value is not. So we want anything above 70 and above to return true. Anything below 70 to return false. That's how we're going to set it up. So let's go ahead and call this function passing score. And once again, we just need, like with the map method, we only need a single parameter with our function, and that's the value as it iterates through each element in the array. And then what are we going to do with that value? Well, we just want to see if it's greater than or equal to 70. Simple as that. Because if it's greater than or equal to 70, it's going to return true. It will be included in the array. If it returns false, it will not be included in the array. So now let's go ahead and set up a new array, pass scores, and then we'll use our scores array and filter. Here's our filter method, and we're passing in a function. Just like that. So if I save that, and let's look at pass scores. Oops. Not the function, we want the array. And there we go. We have the scores eliminated that are below 70. So all of this is showing us some declarative methods that are frequently used with functional programming. They're declarative because we don't have to worry about specifying the loop. That is handled for us. It's abstracted away. It's handled behind the scenes. Now, before I leave this, one last thing I want to say. With each of these functions we've created for these methods, we could have additional values passed into those functions. For example, we could have the index position of the element, and we could have the original array as well. Those are values that we could receive as these functions are used within the reduce method. The map method, I could add those here, as long as I put parentheses around it, and the filter method. And sometimes those values can be helpful in solving a problem that we're working on as well. So just be aware of that. We can get the value of the element, we can get the index position, and we can get the original array. And we have access to the original array already. It's like that, but sometimes it can be helpful to pass that into the function as well. All right, so that is reduce, map, and filter. If you haven't used those in the past, start forcing yourself to make use of those. And I don't think you'll regret it. All right, let's move on.